Welcome to another chapter, and in the previous chapter what we have learned so far is how to create forest using a PCG framework. And we are actually going to use PCG framework just like this, what we've done for forest, but this time we're going to use it for other models that comes with the project itself for this course. And what we're gonna actually go for is first create a fence that will be placed around the racetrack later on. And we are actually going to use this principle of what we have learned, but this time we are actually going to slightly change the configuration. So instead of setting up everything inside the within the spline component itself, we're going to make sure it works on the edges. Hence, we are going to create fences for that. So to do this, we're going to basically pick up some of the models that already exist in the project. So I'm going to use fence for that. And the fence we are going to use this is this one here. So what we're going to do is to create a spline that will basically follow up entirely across the landscape, however you want to. And then it will generate one by one, and we can set up the distance spawning in between as well. So to start off, let's go and create our PCG for that. So I'm gonna create a new folder. I'm gonna make sure it's separate. So in this case, I'm gonna call fence PCG, and I'm going to double click on this, and I'm gonna right click and create a new PCG graph. For this one, I'm gonna call it PCG fence. So let's double click on that one and let's open this up. So now what we need to do is to make sure that actor data that we are going to use this to follow this up will be using spline component. So to start off, we're going to go right click and search for get spline data. Next thing what we need to do is to use spline sampler. And this time, because we've been doing that with the previous exercises, but this time we're gonna keep as it is on spline. I wanna make sure it's set to distance, so we can measure the distance of the spawning, in this case, static meshes. And I'm going to make sure it's unbounded. That means every time we load the app models, it will basically reappear on the spline. So in the next section I'm going to do is to create a transfer node points, and I'm gonna plug this in. And I'm also going to create static mesh spawner. Plug this in. With this all set up, we can comfortably place them the way they are. And I'm going to add for now the fence that we have from our folder. So we're just going to have this prepared for us. Next section is to make sure we are going to create parameters. So parameters we are going to create within this PCG graph. And then we're going to expose them into active blueprint. So the first things, let's start off and create a few of them. Ideally will be two of them we need it, so we'll just remove one. I'm going to rename this to spawn distance. And the next one will be scale. Just to begin with, let me use this spawn distance. We are going to use distance increment here, so I'm going to look for spawn distance. Plug this in, but make sure you also set to at least 100. And I'm going to go and connect this together. And I'm going to also throw this in, close this in, and I'm going next to set up the scale. And also we are going to plug this inside it. And the reason I'm going to use 2 because I want to make sure it goes evenly with minimum and maximum keeping the same value here. So I'm going to set this to default 1. Set this up, so save that. So let's go and jump into creating our active blueprint for that. So I'm going to go to my PCG folder. I'm going back to my fence PCG, right click, and let's create active blueprint. I call it BP_fence. Open this up. Let's add a component, PCG, as always. Make sure it works so it literally is connected to our fence that we've created, PCG graph. I'm going to use this one, drag it into this. And next thing, I'm going to add spline component. Save it. So now what we're going to do is then expose them, make them work in the construction script. So as we do this, we're just going to drag PCG graph. Look for get graph instance. Let's go and set the components, which in this case will be set float parameter. Just to make sure I have the same type of variables, I'm going to also use float as well. So I'm going to add another float, connect this together, and let's say the naming is right. So I'm going to copy this name and stick it here. And I'm going to do the same thing for this one. So I'm going to use scale. And also let's create parameters here. I'm going to call this bounding distance. Set to float. And I'm going to create a scale. Make sure it's public. Also make sure, always remember to compile and or add those values here. So for the minimum distance, I can think of say 100 and maximum to 500. You can also put numbers however you want to, so it's entirely up to you. And also make sure a minimum set to at least 100. So let's put for 100, 150 for now. I'm going to drag and drop in here, plug this to that. Let's do the same for scale. So I'm going to set to 1. Make sure the minimum is 0.5 to like 2. Compile that. Connect to scale. And now we can plug this together, all together. So now we should be ready to go with the whole tool. It works and we can test this out. So I'm gonna minimize that. And now I can just drag and drop into the space here. Grab to one of the points that are exposed in the spline. You can drag it out and see if it works. So now you start seeing a spline is projecting all these fences and makes them generated. But you can see that fences are a bit too close to each other, so we can actually change this very quickly just by increasing the number. So as you can see, they kind of start to being placed properly next to each other. So maybe it's 250 is too much, so maybe set to 220. And you can try and do this as well, so you can expand this. So that will be very useful for our later creation of, this case, fences around the racetrack as well. So the next challenge that I think we should take a look into is to see, depending which direction the fence is facing towards the racetrack, we also want to do it on the opposite direction, but making sure that fence is being swapped to read at 180 degrees. In other words, as you can see that it's facing currently that direction, we also wanted to swap its direction as well. So it's facing at 180 degrees. To do this, we just have to do the same thing what we've done already in the PCG graph, but we need to set out the parameter to rotate the actor, in this case, a static mesh. So it's a very simple thing to do. You can just do that inside the PCG graph. So what I'm going to do is create another parameter. And we're going to call it, in this case, rotate. And because we are going to use, in this case, rotator, we are going to use the only yield direction, which is the z-axis. I'm going to save that. And for this one, we're going to use the rotation values here. So I'm going to right click and search for rotate. And I'm going to make sure I plug this, both of them. I'm going to move this like that. Make a bit more space. I compile that. I go back and I'm going to search for set rotator parameter and make sure it's called the same as what we call it here. So it says rotate. And next thing I want to do is to make sure I right click and break it. I'm going to split it into two. I'm going to only use the yaw in the value here. Let me create another variable. Let's call it rotate angle. I'm going to save that. Is to compile it, but I'm also going to make sure the value ranges between 0 to 180. And the same goes for this, and I'll do the same thing there too. So I'm going to go and compile that, and I'm going to go and connect this to a yaw. Save that again, and let's test this out. So if I put like 50, you see how it all rotates along the spline itself. So I'm going to set this comfortably to 180. So every time you have something to work with, and let's say you wanted to create a fence that happens to be moved away or inwards, or not even away, just being changed direction depending on which part of racetrack is being positioned. You can always change the direction to which direction you want it to be facing. So you go between 0 or 180 degrees. So something that's very useful. And I think will be also very cool is to make sure we also want to close the fence. And let's do the same thing again what we've done previously, but I'm gonna this time do the same thing on the fence. So I'm gonna literally come here and I'm going to close this fence. So I'm gonna create like maybe a button. We can close the fence. So let's see if I can take a spline. Answer is close loop. And basically I've just used this to expose this and make like a parameter. So instead of just basically clicking on this fence here, close loop, I can just create a parameter. It helps to just then use this to be exposed not on the details panel, but it's also much more reachable and also accessible for the, in this case, user to use it in order to just close it loop instead of going and selecting the spline. So that's why it's very handy to create a separate functionality for that. So I'm going to go back and I'm going to make sure I drag it out from the close loop. So let's say we pick up set close loop and I'm going to drag it out and promote to variable. And I'm going to keep it as the name is, make sure it's public. I'm going to compile this. I'm going to set this to none, which is the false, connected. And I'm going to compile that and see what happens. So if I close this, so you see my loop is being closed. So that's very cool because now you have just created a very functional tool that you can use it in any projects in this case, racetrack they're using. And then you can actually create your own effective asset as to help you to create level and landscape very quickly with all the assets you're currently working on, especially with something that relates to splines components as well. So that's why it's very handy because instead of you taking hours to literally generate the results you want, you can just do that within a second. It generates your outcomes just by following the splines and creating a very cool loop around the edges of the racetrack. So this was it for today. And the next lesson, what we're gonna do, we're gonna actually use another set of models, and I already have them prepared for the next part of the tutorial. And under tires, what you'll see, we're gonna use these two assets here. So we're gonna literally have two options. So you can either work with double tires as it being stuck up on top of each other, or have like a single deck of tires. And what we're gonna do is use the same principle what we already done with the fence, but instead we are going to create this functionality where you can swap in between those two. Thank you so much, and I'm really excited to see you in the next lesson where I'm going to be explaining and we'll be working on together how to create a very cool tire barrier tool for that. Thank you and see you in the next one.